Thursday. Ready? Am I recording and stuff? Okay. All right. Radicals. Radicals are expressions that contain roots. I.e. 3 root 2 and root 5. This portion is called the radicand. Just the root 2 part. This is also the radicand. Okay. A mixed radical is like 2 root 3 or 5 root 7. But an entire radical is like root 3 and root 7. So here the coefficient is 1. But here the coefficient is not 1. Entire radical. 8. Radicals that have the same radicand. They can be collected like terms. So if you have 2 root 3 minus 3 root 5, 3 root 3 minus or plus 7 root 5, the answer to this is you can collect this guy and this guy, and then you can collect this guy and this guy to give you 2 root 3 plus 3 root 3. It's going to be 2 root 3 plus 3 root 3. Not over, just root 3. Yeah, it's like 2a plus 3a, 5a, so this makes 5 root 3. And negative 3 root 5 plus 7 root 5 is 4 root 5. Okay. Simplifying radicals. Perfect squares are numbers that can be square rooted to a whole number. I.e. 4, 9, 16, 25, 36, 49, 64, 80, 81, 100, 121, 144. These are all perfect squares. If the radicand is divisible by a perfect square, we must break the radicand down. For example, and you need to work on this, if I give you like 3 root 8, which of these, what's the largest one out of the perfect squares that can divide into 8? What's the largest number that can divide nicely into 8? Yes. You can write this as the root 8 as root 4 and root 2. Because root 8 is really 4 times 2, right? But the square root of 4 is, so then you do this. You say that root 4 is 2. Not root 2, 2. So your final answer is 6 root 2. Sometimes you have to do this in order to break these down. Because if I had given you root 12, and this 12 can be written as root 4 times root 3. This 27 can be written as root 9 root 3. So root 4 is, and root 9 is, final answer is, good. Multiply. To multiply, outsides to outsides, which means coefficients, and insides to insides. So for insides to insides, that means the radicand. So if I give you 3 root 2 times, let's go negative 2 root 14, you would go, what is your answer? If you multiplied these two. Outsides to outsides. Yeah? Good. And then insides to insides. Double that? Yeah. But answers must always be in the most simplest form, simplest radicand form. So we can take a root 4 out of this because root 4 times root 7 makes root 28. Now we get negative 6 times root 7. Negative 12 root 7. Okay. What if you were to minus this? 1 minus root 3 over 2 plus root 2. Actually, let's make it root Let's just make it root 3 here too. How do you multiply binomials? What do you use? Yeah, how do you multiply 2 terms times 2 terms? What do you use? Sorry? FOIL. Yes. Okay. Firsts. So 1 times 2 is? 1 times root 3 is? Good. Because sides to outsides, there's no inside to the 3. So this times this is? Root 3 times 2 is? Good. And then negative root 3 times root 3 is? Yes, minus root 9 though, because it's a negative root 3 times the root 3. Yes, but first you can change this. What's the square root of 9? What's the square root of 9? It's already a perfect square. Yes. So you get 2 plus root 3 minus 2 root 3 minus 3. Not root 3, 3. 2 minus 3 is negative 1. This positive 1 root 3 minus 2 root 3 is minus 1 root 3. That's your final answer. Just tell me when you're ready. Oh my god, I'm going to pass out. I'm so tired. I didn't. I was here doing work. Wake me up when you're ready. You ready? To divide, reduce outside to outsides and insides to insides. So if I give you something like 5, 15 root 28 root 7, this is what you do. You think of it this way. What would you tell me if the answer was 5 over 15? What would you do with that? You'd reduce that to what? Not 3. You can divide them both by? Yes. You can't say 3 because that means 3 over 1. So if you divide this number by 5, what do you get? You divide 5 by 1, what do you get? Or if you divide 5 by 5, what do you get? If you divide 15 by 5, what do you get? If you have 28 and 7, those reduce both by 7. So you can divide root 7 divided by root 7. Root 28 divided by root 7 is root 4. So you get this. So you reduce the outsides to outsides, and then you reduce the insides to insides. And then simplify if you can. Square root of 1 is? What's the square root of 1? What's the square root of 4? So you get 2 over 3. rationalize. So the last thing. It's definitely one on your test. You are not allowed to leave a root in the denominator. To eliminate the root, rationalize. There are two cases. If you have a monomial denominator, monomial means it's only one term. You multiply by the entire radicand in the denominator. To both the top and the bottom. So if I give you 3 root 6 over root 7, 2 root 7 I should say. If I give you this, you can't reduce anymore because 3 over 2 doesn't reduce. 6 over 7 doesn't reduce. So you can't do any reducing or dividing, but you're not allowed to leave a root in the denominator. This is always on the test. It's worth 5 marks on the test. You multiply by the entire radicand from the bottom, so root 7 over root 7. See, in math, it's okay to multiply by 1, and that's really multiplying by 1. So now when you multiply, what's 3 root 6 times root 7? What's 3 root 6 times root 7? So outsides to outsides, insides to insides. 42. 6 times 7 is 42. Then inside to insides, or outsides to outsides, and you get 2. Root 7 times root 7 is root 49. Then what you do is, this will turn into a perfect square. So you get 3 times the square root of 42 over 2 times 7. Because the square root of 49 is 7. Not root 7, just 7. So then you get 3 root 42 over 14. And you can't reduce any further. But if you have a binomial denominator, you multiply by the conjugate radical. The conjugate radical has the same 2 terms, different between. I.e., 3 root 5 minus 2 root 3, and 3 root 5 plus 2 root 3. Those are conjugate radicals. The same 2 terms, but different signs in between. So what happens if you get a number like 3 root 2 over 3 root 5 minus 2 root 3? You're not allowed to have that. By the way, you can't cancel the 3 and the 3. When there are plus or minus signs, you can't cancel between only two of them. You can only cancel if everybody has it. So what you do is you multiply by the conjugate radical, 3 root 5 plus 2 root 3. It's good to put brackets around this, and then you FOIL. Okay, or distribute. So 3 root 2 times 3 root 5, Maya, is? What's 3 root 2 times 3 root 5? Good. What's 3 root 2 times 2 root 3? Good. Nope, there's nothing you can do there. Then you FOIL out here. 3 root 5 times 3 root 5 is? This times this. 3 root 5 times 2 root 3. This one times this one. 3 root 5 times 2 root 3. Good. Here to here is? Good. And here to here is? Good. This can simplify? Yeah, very good. 9 times 5, because the square root of 25 is 5, not root 5, 5. So you get 45 here. These guys cancel. That's what was going to happen. And then you have root 9, which is 3, so minus 12. So final answer is 9 root 10 plus 6 root 6. Actually, not the final answer yet. Over 33. But you can reduce everybody by 3. Only if everybody can do it do you do it. So the final answer is 3 root 10 plus 2 root 6 all over 11. What was the point? Why did we have to rationalize? What are we not allowed to have? That's right. Not allowed to have a root in the bottom. Notice that both times, once we rationalize, we don't have that. That's radicals. All right, Nick, stop. I need a nap.